Hello! In this video, we want to complete part C of the exercise on Mohr's circle. In part A and part B that were covered in the previous video, we determined the principal stresses and their directions. In part C, we are given the rotation angles of the coordinate system, which are plus 30 and minus 30 degrees, and we are asked to compute the normal stresses and the shear stress. How do we do that with the help of Mohr's circle? Before I show you, let's take a look at the initial coordinate systems and the area elements in the rotated counterparts. Here, the rotation is counterclockwise because the angle is positive. And here, it is clockwise from the initial x-axis because the angle is negative 30 degrees. To avoid confusion, I have labeled the rotated axes x star and y star in this scenario, and x prime and y prime in this situation. The directions of stresses are indicated, that is, the mathematically positive directions. For shear stresses, I'm using just one tau for convenience because otherwise it will get too cramped with the symbols. So how do we find the magnitudes of the stresses in the rotated coordinate systems with the help of Mohr's circle? First of all, as you know from the previous video, measured angles in Mohr's circle typically give you 2 times alpha, or 2 times whatever the symbol you use for the angle. Having this in mind, you need to draw a line that encloses an angle of 2 alpha between that drawn line and the existing line connecting P1 and P2. If the rotation angle is 30 degrees, as in the first scenario, 2 times alpha must be 60 degrees, and because it is positive 60 degrees, it must be 60 degrees counterclockwise from the new line to the old line between P1 and sigma m. In this regard, to find the direction of the new line, you need to go 60 degrees clockwise from the line sigma m P1 to the new line sigma m P1 star. This time, I have a protractor that I can use to measure the angles. I'm gonna place the protractor so that 0 is right on sigma m. And because I'm looking for the new line that has an angle of 60 degrees to the old line, I have to go 60 degrees clockwise from the old line sigma m and P1. 10, 20, 30, 40, 50, 60. And I'm going to mark a point here. Let me remove the projector. And now I need to draw a straight line that connects this point, sigma m, and the intersection with the perimeter in the lower tau region. That's my new line. And the intersections between the new line and the perimeter will be labeled as P1 star here and P2 star here. I am putting the star to indicate that the stress coordinates will correspond to an angle of 30 degrees to the initial x-axis. Okay, and for reference, I will also label this angle, which is 60 degrees between the old line and the new line. Now, how do we identify the stress values? Well, P1 or P1 star has the coordinates sigma x and tau xy. So P1 star, therefore, is going to give us sigma x star and tau star. And to find sigma x star, we have to check what is the sigma coordinate of this point P1 star. And to do that, I will draw a thin vertical line connecting P1 with the sigma axis. So this line, I would say, looks vertical, and if you use the scale that we talked about in the previous video, you will determine that the stress value sigma x star should be roughly minus 7.5 megapascal. So let's record that value. Sigma x star is equal to minus 7.5. The 5 could look better. Megapascal. Okay. Tau xy or tau star xy can be found by looking up what is the tau value at point P. And as you can see, it is hardly different than tau max. So I would say it's 10, 20, 30, 40, well, let's say 46 megapascal. And what is sigma y star? To find that magnitude, let's look at P2 star and determine the sigma coordinate of P2 star. And if we draw a thin vertical line again from the sigma axis to the point, then we see that sigma y star is roughly equal to 20, let's say minus 22 megapascal. Okay, all you need to know is that if you want to find the stress values in analogy to P1 and P2, you need to check what are the coordinates with respect to the sigma axis and tau axis for P1 star and P2 star. And then you just read out the position of the coordinates and you write down the corresponding stress values for a rotation angle of 30 degrees counterclockwise to the initial x-axis. In the next step, we will perform the calculation for a rotation angle of minus 30 degrees. In the meantime, I will erase the drawings here to make space for the new angle. We are back. In the second scenario, alpha is minus 30 degrees, so 2 times alpha must be minus 60 degrees. And minus 60 degrees is the angle between the new line and the line P1 sigma m. So to find the direction of the new line, we need to go 60 degrees counterclockwise from the line P1 sigma m. I will again use my on-screen protractor. I will place it so that 0 is right on sigma m. And if we go 60 degrees counterclockwise from this blue line, we will end up at 10, 20, 30, 40, 50, 60. So we'll mark a dot here so that we know which point to connect. And the new line connects the new point with sigma m and the perimeter on the right side. This intersection will be labeled as P1 prime because we are gonna use primes for this scenario. And this point will be labeled as P2 prime. So the angle of 60 degrees is always from the line sigma m P1 to the line sigma m P1 prime. Remember how you read out the stress values. For P1 prime, we have sigma x prime and tau prime, and sigma x prime is here on the sigma axis. 1, 2, 3, 4, 5. Well, looks like it's roughly minus 59 megapascal. Tau what is the location of tau prime on the tau axis? I will draw a horizontal line to find out the precise location of tau prime. That's roughly minus 16 megapascal. And finally, the location of sigma y prime. So let's look at P2 prime and draw a vertical thin line from that point to the sigma axis. That's gonna be roughly positive 29 megapascal. not negative, it's going to be positive. So here you go. This is how you read out the coordinates of sigma x prime, sigma y prime, and tau prime. And if you know the coordinates, and if you know your scale, you can get your estimated stress values. That's it, folks, about Mohr circle, and I'm looking forward for the next topic.